ओके, सो कैन यू टेल मी बेटा नंबर 8 में इनिशियल फाइनल पोजीशंस क्या हैं?
सर इसमें वर्टेक्स का लैटिट्यूड है 51 डिग्री,
बेटा पहले मुझे इनिशियल और फाइनल पोजीशंस बता दो।
सर इनिशियल पोजीशन इज 10 डिग्री साउथ and longitude is 150 degree west.
Okay, just a minute. 10 degrees south and 150
west.
ठीक है बेटा.
And final position is 40 degree north.
Okay.
160 east.
All right. And limiting latitude is also given. This is GC और composite बेटा?
सर GC का ही है, ये क्वेश्चन नंबर 3 पे पेस्ट है और फिर 8 इसका पार्ट
GC है और इसमें हमें वर्टेक्स का लॉन्जिट्यूड निकालने में डाउट आ रहा है, करेक्ट?
वर्टेक्स का लॉन्जिट्यूड तो आ गया, फिर उसके बाद we have to find the longitude where this great circle crosses the equator.
Okay, all right. ठीक है बेटा. Let me make the diagram. So 10 south.
Vertex के
just tell me one thing, is the vertex coming inside or outside?
Outside.
Outside, okay.
On the B side.
Oh, sorry.
सर दूसरा साइड बनेगा ये.
Yeah, that's right. So this is how the diagram must be coming up, beta.
Yes, sir.
Very good.
Yes, sir.
Now you tell me, beta, intermediate position इन्होंने क्या पूछी है?
We have to find where this great circle crosses the equator.
Where the great circle crosses the equator. Okay, all right. So just give me a minute. This is 150 west. This is 160 east. तो सबसे पहले तो हम diagram बनाएंगे like this. Now in this diagram we can show the equator also. The equator is going to be somewhere here. So this is the place or point, the position which we need to find out. Let's name it as X. And let's draw its meridian also. So that becomes PX. Now this is a pretty simple question actually. Very simple question. Because इसमें जो P2X side है वो 90 डिग्री हो जाएगी. P is the pole and X point is on the equator. So this PX side is going to become 90 degrees. So for finding X, actually we do not need the vertex. We can find the value of X without the vertex also. You can use triangle PAX or PBX and you can find the vertex. Now the issue is coming in finding its longitude, right beta?
Yes, sir.
Okay. So which angle have you calculated? Can you tell me beta? Which triangle you have used?
PAX, sir.
PAX triangle you have used. So you must have calculated this particular angle P, right?
Yes, sir.
Okay. How much is this angle coming, beta?
8 degree 4.3.
Very good. It is coming as 8 degrees 4.3 minutes. So मैंने इसे यहाँ पे लिख दिया है. This is the angle. Now you see beta, this angle P, the red color angle which we have marked, is the angle at the pole contained between meridian of A and the meridian of X. So this is the D long between A and X. Now if we apply this D long to our initial position A, we should get the longitude of X. Now the issue is how to apply it. Now always remember beta, in these triangles which we are making, the diagrams which we are making, the directions are always maintained accurately. Means you go upwards, it will be north direction. You come downwards, it will be south direction. You go towards the right, it will be easterly direction. You go towards the left, it will be westerly direction. Now when you are going from A to X, which direction you are going, beta? Easterly or westerly?
Westerly, sir.
So when we are going from A to X, we are moving in a westerly direction. Now if this is a westerly direction, that means the D long is also westerly. Now A's longitude was 150 west. D long is 8 degrees 4.3 west. So what will be the longitude of X? It will be, both will be added up since both are in the westerly direction. So it will become 158 degrees 4.3 minutes. Correct, beta? Is it, were you able to understand?
Yes, sir. सर एक्चुअली मेरा डाउट था वर्टेक्स में, जब वर्टेक्स का जो लॉन्गिट्यूड निकालते हैं तो उसमें जब पी की वैल्यू आती है तो उसमें उसका ईस्ट वेस्ट डायरेक्शन कैसे लेना है?
ओके, वो भी कर लेते हैं बेटा, इसी क्वेश्चन में कर लेते हैं. हैव यू डन दिस क्वेश्चन बेटा?
मैंने भी क्वेश्चन किया था, इसमें मैंने PVX ट्रायंगल यूज किया था. तो जो लॉन्जिट्यूड ऑफ V है उसमें मैंने 90 डिग्री, ये 90 डिग्री आया था ना वो P का वैल्यू,
राइट.
इन ट्रायंगल PVX.
राइट, ठीक है बेटा.
तो 90 डिग्री से मेरे को ये डाउट हो रहा था कि 90 डिग्री प्लस करना है उसमें कि माइनस करना है.
ओके.
तो फिर ये करके करा मैंने कि इन दोनों लॉन्जिट्यूड A और B के बीच में, A और V के बीच में ही होगा ये लॉन्जिट्यूड, तो उससे फिर किया.
ओके, दैट आल्सो कैन बी चेक्ड, बट बड़े इजीली आप चेक कर सकते हो. वर्टेक्स का लॉन्जिट्यूड क्या आया था बेटा?
111 degree 55.7 east.
Okay, so let's write it as 111 degrees. I'm leaving the minutes just to keep it simple. 111 degree east. Now vertex is 111 east. You have calculated this green color angle which comes as 90 degrees. So 111 east से आप 90 degrees और east में जा रहे हो, because from the vertex if you come to X, you are moving towards the right. That means the easterly direction. So in this case, the longitude would be 111 east plus 90 east. ये ऐड हो जाएगा, और जब आप इसे ऐड करोगे तो आपका आंसर क्या आएगा? The answer would be 201 east. करेक्ट बेटा?
हाँ यस सर, उसके बाद फिर 360 से माइनस कर दिया.
अब जब भी कभी आपका लॉन्जिट्यूड 180 से बड़ा आ जाए तो आपने क्या करना है? यू हैव टू सब्ट्रैक्ट इट फ्रॉम 360, एंड जब आप 360 से सब्ट्रैक्ट करोगे उसके साथ ही हमें चेंज करना होता है इसका नेम. सो 360 minus 201 and you change the name from east to west. सो ये आपके पास बेटा 1584.3 का आंसर आ जाएगा. सो यू विल गेट द सेम आंसर.
सर इसको वो कंसेप्ट से भी कर सकते हैं ना कि वर्टेक्स से 90 डिग्री अवे होता है ये वाला पॉइंट.
बिल्कुल बेटा, इसमें एक्चुअली नेपियर रूल लगाने की ज़रूरत ही नहीं है.
तो एग्जाम में अगर ये आए तो सर डायरेक्टली हम लोग लिख सकते हैं ये चीज.
Yes बेटा, yes, you can write the statement that we know the vertex is 90 degrees away from the equator crossing points, so the d long has to be 90 and you can calculate it. No need to apply Napier's.
ओके ओके, तो वही सर ये हो रहा था कि एक तो यहाँ पे कट करेगा, एक दूसरे साइड भी कट करेगा ना, तो हम लोग को आंसर में ये इसके जो बीच में आ रहे हैं वही वाला लेना है.
That will be the opposite equator crossing point. हमें वो equator crossing लेना है जो हमारे ट्रैक में आ रहा है.
हाँ ये सर.
ओके, अब बेटा दूसरे डाउट पे चलते हैं. सबसे पहले जिसने डाउट पूछा था, हिज डाउट वाज समथिंग एल्स, तो ये तो क्लैरिफाई हो गया. बेटा आपका डाउट आप एक बार मुझे फिर से बताओ क्या था.
सर जब वर्टेक्स का लॉन्गिट्यूड निकालते हैं तो जब उसमें वैल्यू ऑफ पी आती है उसमें उसका नेमिंग कैसे लेना है ईस्ट वेस्ट, उसमें बार बार डाउट.
बेटा इसी क्वेश्चन में समझा दूं आपको या और कोई क्वेश्चन ले लें?
इसी में बता दूं.
इसी में बता देते हैं. लेट अस इरेज द अननेसेसरी थिंग्स. इक्वेटर क्रॉसिंग पॉइंट हमने ढूंढ लिया है, इसको अब इरेज कर देते हैं. वी डोंट नीड इट. सॉरी, erase this also, not required. Okay, let me draw the meridian of the vertex. Okay, now बेटा इस क्वेश्चन में हमें वर्टेक्स की पोजीशन को ढूंढना है. सो वर्टेक्स की पोजीशन ढूंढने के लिए सबसे पहले तो हमें निकालने पड़ेंगे एंगल ए और बी. लेट मी मार्क देम इन ए डिफरेंट कलर. सो पहली आइटम हम निकालेंगे एंगल ए, फिर दूसरी आइटम हम लोग यहाँ पे पता करेंगे एंगल बी. इन दोनों एंगल्स को देख के हमें पता चलेगा वेदर द वर्टेक्स लाइज इनसाइड और आउटसाइड. सो हमने ये एंगल्स निकाले. लेट अस अज्यूम, आई एम टेकिंग हाइपोथेटिकल फिगर्स टू जस्ट एक्सप्लेन द कॉन्सेप्ट. लेट अस से ए एंगल जो है ये आता है 40 डिग्रीज एंड बी एंगल कम्स टू बी 110 डिग्रीज. सो इस केस में angle B is a obtuse angle or greater than 90 degrees. So we know that the vertex has to be outside the triangle. So we can make the vertex anywhere outside the triangle towards the side of V. मैंने ये point ले लिया और vertex को बाहर बना दिया. So पहले तो ये diagram बन जाएगी बेटा. Up to here is clear?
Yes sir.
अब बेटा हमें इन दोनों में से एक ट्राइंगल को कंसिडर करना है. पापा अल्फा विक्टर और पापा ब्रेवो विक्टर. विच ट्राइंगल यू वांट टू टेक?
अल्फा पापा विक्टर.
ओके, सो हमने ये ट्राइंगल ले ली. अल्फा पापा विक्टर और पापा अल्फा विक्टर बिगर ट्राइंगल, इसको हमने कंसिडर किया. दिस इज ए राइट एंगल ट्राइंगल. इसमें दो चीजें हमें पता हैं. वन इज साइड पी ए विच वी नो एंड सेकेंड इज एंगल ए विच वी नो. इन दोनों के साथ हमने नेपियर रूल में एंटर किया और हमें मिलेगा ये वाला एंगल P. सो एंगल P हम नेपियर रूल से कैलकुलेट कर सकते हैं. गिव मी एनी वैल्यू ऑफ योर चॉइस फॉर एंगल P बेटा. कोई भी वैल्यू दे दो मुझे.
सर 98.
ओके, लेट अस से ये एंगल P जो है ये 98 डिग्रीज आ जाता है नेपियर रूल अप्लाई करने पे. नाउ this angle is the angle at the pole contained between meridian of A and meridian of the vertex. So this is the D long between A and vertex. A का longitude है 150 degree west. It is given to us. It is the longitude of A. Now you tell me, when you go from A to the vertex, Are you going in the easterly direction or you are going in the westerly direction?
Westerly, sir.
I'm going in westerly direction. So that means this, very good. So this D long should be westerly. That means from 150° west, I'm going 98° west. So initial longitude west, D long is also west, so they will be added up. So if you add up, it comes to 248 west. So this should be the D long of our vertex. अब कभी भी D long की वैल्यू 180 से ज्यादा नहीं हो सकती. If in any calculation the D long comes greater than 180, what do we do then? We subtract it from 360. 360 से हम इसे माइनस करते हैं. ओके, सो ये कितना आ गया बेटा? 112 degrees.
So 112 degree.
वेरी गुड. 360 से इसे माइनस करते हैं और जो इसका नेम होता है वो चेंज कर देते हैं. सो when you do that, you get the value of 112 degrees east. This is the longitude of our vertex. So अब बताओ बेटा, is this getting clear in the mind?
Yes, sir. Clear है, sir. Thank you.
Very good. और कोई डाउट बेटा? All clear? Okay, great. अब बेटा मुझे एक बात बताओ कि जो हमारा लास्ट सेशन था उसमें मैंने आपको composite sailing कंप्लीट करवा दी थी. Did I tell you how to calculate all the parameters? Initial course, final course,
No,
total composite distance. Okay,
No,
okay.
sir. Start नहीं हुआ.
Okay. Composite हमने शुरू नहीं किया ना? Okay. I missed out. वो एक्चुअली जो सेकेंड फेज 1 बैच है विच इज रनिंग, सो उसमें भी यही जॉब टॉपिक चल रहा है. सो देयर आई हैड कंप्लीटेड. डोंट वरी. ग्रेड सर्कल में बेटा हमने इंटरमीडिएट पॉइंट्स कंप्लीट कर लिए थे.
Yes, sir.
Okay. So you are able to calculate intermediate points now?
Yes, sir.
ट्राई आउट किए थे क्वेश्चन बेटा? जीसी एक्सरसाइज से क्वेश्चन ट्राई आउट किए हैं? आर यू गेटिंग आंसर्स?
Yes, sir.
Yes, sir.
Very good. So then it is time to proceed to composite sailing. So ठीक है बेटा, let's continue with the composite sailing now. All your doubts cleared. किसी को कोई और भी डाउट है तो अभी क्लियर कर लो. The mind should be clear before we go ahead.
No, sir. All set.
Okay, very good beta, all set. So let's understand the concept of composite sailing. I'll again show you a video presentation. So we will see what composite sailing is, why is it required, and how the calculation is done. So ये सारी चीजें हम देखेंगे. To give you a understanding of this composite sailing, composite word का meaning होता है something consisting of more than one. It's a unit having more than one component. So ये जो हमारी composite sailing है इसमें भी दो sailing का combination है. So that is why it is called composite sailing. कौन सी दो sailing है ये? One is GC sailing and the second one is parallel sailing. Parallel sailing means moving along the parallel of a latitude. So when you move parallel to the equator or you move along the parallel of a latitude, it's called as parallel sailing. Parallel sailing का formula याद है बेटा? Anyone remembers? Parallel sailing formula, departure is equal to?
Departure is equal to distance into cos theta.
Very good. Very good. Departure is equal to d long into cos of m lat, or you can say departure upon d long is equal to cos of mean lat. So that is the formula which we use in parallel sailing to calculate our distance. Departure is nothing but the east-west distance between any two places on the surface of Earth. So we will use this parallel sailing formula and we will see how the composite sailing is done. What is the need of composite sailing? The need is beta, great circle sailing has a big disadvantage. What is the most famous incident in shipping world? Incident.
About
Titanic.
Most famous accident in shipping?
Titanic.
So no doubt about it, Titanic. Titanic happened because of iceberg. So iceberg is one of the dangers of high latitudes. Now great circle sailing इसकी एक disadvantage है. Disadvantage ये है, the great circle track takes us into higher latitudes which may be higher than the latitude of our starting position and our destination. Rumbline sailing में कभी ऐसा नहीं होता. When you go from one place to another using a rumbline track, you will never exceed one of those two latitudes. But great circle sailing में you could be going into latitudes which are higher than the latitudes of both the positions. अब higher latitudes have their own set of problems. Iceberg, as we just now saw, that's a big danger to the safety of the ship. And not only iceberg, you have numerous other dangers in high latitudes. That could be sub-zero temperatures. There could be ice on the surface of water. When the ship moves, it may hit the hull and the hull may get ruptured. It will hit the propeller and the rudder, and if they are not strong enough, the rudder and propeller may just break. If there is thick ice around the ship can get stuck. It is known as vessel getting beset. There is a danger of ice accretion. If there's continuous snowfall or because of high winds, there's a lot of spray coming on the deck of the ship, ice could accumulate and that could put the ship in negative stability, leading it to capsize. There could be sub-zero temperatures which may interrupt in your fuel supply. The fuel may become thicker. The staff will have their difficulties. Any deck machinery will have problems of its own. If the lines are not drained, they will rupture. So all these dangers are there in high latitudes, and we would surely like to avoid them. So we want to save the distance, but not at the cost of putting our ship in danger. So this is a major disadvantage of great circle sailing, and it may take you to these dangerous latitudes. And to avoid them, what we do is a combination of GC sailing and parallel sailing. This combination, which we call as composite sailing, avoids the high latitudes. So we are saved from all these dangers and at the same time gives us a distance which is shorter than the rumbline sailing. So we take advantage of the saving in distance as well as we avoid all these dangers in composite sailing. So let's see now how do we do this composite sailing from a practical example on the surface of Earth. Any one of you has done composite sailing on board?
No sir, मैंने तो नहीं किया.
Okay, all right. So this is new for all of you. Good. You will be able to do it once you attend the lectures. So ठीक है बेटा. Let me set up the video presentation now and let's go into composite sailing. Anything you want to ask before we go into the presentation?
सर मतलब कैसे ये कंपोजिट सेलिंग कैसे कि हम जीसी ट्रैक पे भी चल रहे हैं और रम लाइन पे भी चल रहे हैं दोनों ऐसा?
नहीं बेटा, एक साथ तो दोनों पे नहीं चल पाएंगे.
तो फिर मतलब टुकड़ों में चलेंगे कि जीसी ट्रैक बन गया और रम 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 रम
जापान आ गए तो कंपोजिट हो जाती है.
Right. Sometime on a GC track, sometime on a parallel track.
सर जीसी भी तो रम लाइन में ही तो ब्रेक डाउन होता है बेसिकली.
No, beta.
यार
No,
एक
no,
probably
no.
तो
That's
टाइम पे जीसी करते हैं, फिर रमलाइन करते हैं, फिर उस पॉइंट से फिर जीसी करते हैं, राइट सर?
yes. Yeah, that's right, Chetan. That's right, beta. So शिवांग बेटा, जो GC को रमलाइन में हम कन्वर्ट करते हैं, you are right, but it is still a GC track. You may break it up into small rambline tracks because you cannot follow the curved path continuously.
हाँ.
Okay, but it is still called a GC track. You try to go as close to the GC as possible. Okay, we consider it as GC track only. Okay.
तो फिर ऐसा कहाँ पे करेंगे, जैसे ऐसे कोई, जैसे दोनों एक साथ कहाँ पे कोई एरिया, जैसे फॉर द एग्जांपल यहाँ से यहाँ तक ही है.
अभी देते हैं बेटा एग्जांपल. Anybody gone from Japan to US?
गया सर, मैं खुद गया हूँ.
एल्यूशन आइलैंड्स के नीचे रम लाइन मार.
हाँ सर गए हैं सर.
वो जीसी हो जाएगी फिर बाद में.
जीसी मारते हैं बट सर एल्यूशन के नीचे उसको चेंज करना पड़ता है बिकॉज ऑफ दैट.
Right, right. So अब इसी चीज को देखते हैं. Let me show you in the video. Okay. So just give me a minute. I'll set up the video.
Let us quickly brush up our concepts of parallel sailing, which I'm sure all of us are aware of.
Beta, are you able to see the video and the audio clearly?
Yes, sir.
Okay, all right.
Now, when a vessel sails along a given parallel of latitude, that means along an easterly course, that is 090 degrees true, or a westerly course, that is 270 degrees true, the sailing is referred to as parallel sailing. We already know why it's called parallel sailing, because you're moving along a given parallel of latitude. Now, departure is the east-west distance between two places expressed in nautical miles. So please note, it has to be expressed in nautical miles, and it needs to be the east-west distance between the two places or points. Now we have a parallel sailing formula, which gives us a relationship between d long and departure, and we all know it. Cosine of latitude is equal to departure upon d long. Obviously, this cos lat cosine is a trigonometric ratio. So obviously the units of departure and d long will be same.
So just note down the parallel sailing formula, beta. This is what we will be using in composite as well as in later questions.
So obviously the units of departure and D long will be same. So here we have the world map on the screen. Let us say we need to depart Tokyo in Japan, which comes up on the screen marked as point A, with its coordinates also showing up. And we need to reach Seattle in United States, which also comes up on the map marked as point B, with coordinates of the Seattle also showing up on the screen. Obviously, our preferred route shall be great circle sailing to save on time. And in this case, you can see it shall be across the 180th meridian, across Pacific on an easterly track. Now, let us quickly draw a PAB triangle between Tokyo and Seattle on the globe. Here we have point A representing Tokyo. Here we have point B, Seattle in United States. We join them with a shorter arc of great circle. So this is from A to B, the arc, great circle track between A and B. This is the vertex of this great circle track. So we have the GC track from A to B, as well as the vertex of this track. Now we can see in this case, the GC track is easterly because the D long from A to B is easterly. Let's now draw the meridians of A and B. So the two meridians come up on the diagram, and what we get is a PAB spherical triangle, which we all know that if enough information is available, can be solved. Now this white track out here is the rhumb line track between the two locations, and we can see that the rhumb line distance obviously is greater than the GC track, and therefore the preferred track shall be the GC track from A to B.
Okay, so beta, now you can see a actual PAB triangle on the surface of Earth. So A, our starting position, B is our destination. You can see the great circle track marked in the pink color. You see this dotted line also, this shows you the complete great circle around the Earth, which the ship will be following. Now, the white color track which you see is the rhumb line track. Rhumb line track appears as curved here because we are making it on the globe right now. On a Mercator chart, this will appear curved because of the deformation in the projections. So you can very clearly see here that the great circle track is shorter, and it will give you the shortest distance between A and B. Now, another important thing to note here, you can see these parallels of latitude, the black color circles, these are the parallels of latitude. Now, the B point latitude is this one. This is the parallel of latitude of B. And you see the pink color track is going into much higher latitudes than the latitude of B or the latitude of A. So both these latitudes are less than the latitude where the great circle track is taking you. Now there could be, in this case, the great circle track may be going over land, over non-navigable waters. Even if it is in navigable waters, going in so high latitude would take you maybe to the ice limits. There could be a danger of ice present in that area. So this is the danger in great circle sailing. Now we want to avoid these high latitudes. So to avoid them, we will now see the concept of composite sailing. So rhumb line track is shown here, the great circle track is shown here. Now we will see these things on the Mercator chart. How do they appear on the Mercator chart? And we will also have a peek into how these tracks appear on a mnemonic chart. So we will see them on all the three projections. Any doubt up to here, beta?
No.
Beta, your voice was very, very low. Can you repeat?
No, sir.
Okay, great. Let's continue then.
For the sake of clarity, let us see how these two tracks, that is the GC track and the rumb line track, would appear on a Mercator chart. Now, this is how the tracks would appear on a Mercator chart. On Mercator chart, the GC track would be a curved track and a rumb line track would be a straight line track. We all know that on Mercator charts, because the meridians are parallel straight lines, therefore the rumb line tracks are straight lines. Now here it may appear that GC track is a longer distance, but that is not so. It is the GC distance along the GC track which shall be the shortest distance. How would these two tracks look on a mnemonic chart? Let's look at that. Now here we have how it would look on a mnemonic chart. On a mnemonic chart, it's polar mnemonic. GC track would be a straight line and rumb line track would be a curved track. So hope these two comparisons also bring in clarity about how these tracks appear on different projections.
So this is how the tracks appear on these two different projections, beta, Mercator projection and mnemonic projection. Okay, so let's continue further.
Now, having appreciated as to how these tracks appear on different projections, we come to the most important part of our discussion. And for that, we go back to the PAB spherical triangle constructed between Tokyo and Seattle a while back. Now on this globe, we can see this PAB triangle with this one being the GC track between A and B. On examining this track, what do we see in this part of the track? We see that some part of the track appears to be passing over land or maybe non-navigable waters. Now, this could be one reason, or there can be other contributory factors also, which may force a vessel to decide on the highest latitude that it would not like to cross during her voyage. The highest latitude that the vessel would like to reach and not cross is referred to as limiting latitude. Let us say, factoring in all the requirements, in our case, let us say we decide to limit the latitude to 50 degrees north. Here comes the parallel of latitude of 50 degrees north. And now obviously it's very clear that the vessel cannot go from A to B along the GC track because some part of it is crossing the limiting latitude.
So beta, this limiting latitude which we see now is decided on if there is any navigational obstruction, there are any non-navigable waters, or if you check out your routing chart of the area, a routing chart of the Pacific Ocean, or the sailing direction or pilot books or the weather reports. So these are the sources of information which we will be referring to. The routing chart and sailing directions pilot books will tell us what is the latitude beyond which you will have maximum probability of ice. What is the ice limit beyond which icebergs are expected. It will also tell us what are the areas, what are the latitudes where restricted visibility, fog, rough weather, heavy swell, gale force winds, all these difficulties are expected. So we can avoid those latitudes. So weather reports will give you the up-to-date scenario of the weather in that area. So with these, the master and the navigating officer, they decide upon the limiting latitude. In this case, they have decided upon 50 degrees north latitude. So they do not want to go northward of 50 degree north latitude in any case. If we follow the great circle track, it is crossing this latitude, it is going in higher latitudes. We don't want that. And if we follow the rumb line track is not crossing the limiting latitude, but then there is no saving in distance. Rumb line track is much longer. We want to have the saving in distance, but at the same time, we do not want to put our ship in danger. So for this, now we will be finding a way out in the form of composite sailing. So up to here is clear, beta? Any doubt up to here?
No, sir.
Very good. Let's proceed ahead.
In such cases, to strike a balance between the shortest possible distance and also meeting the requirements of not crossing the limiting latitude, the vessel may use combination of sailing. In this case, combination of great circle sailing and parallel sailing. What does the vessel do? Vessel figures out a GC track whose features include A, it passes through departure position A. 2, it has its vertex on the limiting latitude. So here is the GC track passing through A with its vertex being here on the limiting latitude.
Okay, beta. Now this is what we do in composite sailing. We do not move on the original pink color GC track. We follow a separate great circle track. Which great circle track do we follow now? The blue color track which you see now is the one we are going to follow. How is this track decided? Whatever track we follow should be passing from our starting position A. The ship is here, so obviously the track has to pass from position A, then only the ship can follow it. And the second condition is it should be such a great circle track whose vertex lies on our limiting latitude. Now you can pass infinite number of great circle track from the starting position A. Any number of great circle track can pass through it. We are interested in that track whose vertex lies on our limiting latitude. इसका मीनिंग ये हुआ बेटा कि अगर हम A से प्रोसीड करना शुरू करते हैं तो ये ट्रैक जैसे ही लिमिटिंग लैटिट्यूड को टच करेगा दैट पॉइंट will be the vertex of this particular track. So have you understood this beta? Okay, so I take silence as everybody understood this concept. So let us proceed ahead then.
V1 represents the vertex of this blue GC track AV1. Now, this is a GC track, obviously. This is the meridian of V1, the vertex.
So now we know beta this point where the great circle track touches the limiting latitude. This is the vertex of this particular track. So we named it as V1. And what we have done is we have drawn its meridian. Can you tell me beta what will be this angle V1?
90.
Very good.
90.
Very good beta. Very good. So we know that this angle is 90 degrees because at the vertex great circle track is east-west and meridian runs north-south. So this angle is always 90 degrees angle. So if this is a 90-degree angle, now you concentrate your attention to this triangle PAV1. This becomes a special spherical triangle. It's a triangle on the surface of a sphere and all three sides are arcs of great circle. PA is the meridian of A, PV1 is the meridian of vertex 1, A to V1 is a GC track. So we have a special spherical triangle. We can apply the Napier's rule also if required. So let's proceed ahead from here.
We all know that this meridian will make an angle of 90 degrees at V1. So what do we get? We get this shaded right angled spherical triangle. PV1A is a right angled spherical triangle. Likewise, we figure out a GC track passing through B, again having its vertex in the limiting latitude. So you can see this one. Here is the vertex of this GC track marked with V2. So what is BV2? It's an arc of great circle passing through B, having its vertex in the limiting latitude.
So beta, what we did with our starting position, the same thing is done with our destination. So since we are not following the original pink color track now, we follow another great circle track. This is the third great circle track now. First was the pink one, which we rejected. Then the second one was the track passing from our starting position, going to V1, AV1 track. Now this is a third great circle track. It is separate. It's a different great circle. This great circle is passing from our destination position B, and it has its vertex on the limiting latitude. So Bravo Victor 2 is such a great circle passing from the destination position B and having its vertex as V2 on the limiting latitude. So this angle V2 will also be 90-degree angle, and you see this triangle Papa Victor 2 Bravo is also a special spherical triangle now. So if required, we can apply the Napier's rule also in this particular triangle.
Here is the meridian of V2, and obviously this will also make an angle of 90 degrees with the GC track. We get another right angled spherical triangle PV2B shaded out here. Now we get two right angled spherical triangles PV1A and PV2B. Vessel moves along this arc of great circle, so this becomes GC track. Vessel also moves from V2 to B, that becomes a GC track. And from V1 to V2, vessel moves along this parallel of latitude so that it does not get crossed, and that becomes a parallel sailing track. So V1 to V2 is parallel sailing track.
So beta, this basically sums up the composite sailing diagram. You see, we started off from position A, moved on a GC track up to Victor 1. So this was GC sailing. From Victor 1, we moved on a parallel track, moving along the parallel of latitude of 50 degrees north, which is our limiting latitude. We reached at V2, and from V2, we moved on the second great circle track on our passage, Victor 2 to Bravo, and finally reached our destination. So since it involves GC sailing and parallel sailing, two different types of sailing, it is known as a composite sailing. So up to here is clear to everyone, beta? ओके ग्रेट
सर
हाँ बोलो बेटा
सर मतलब V1 से हम तब तक चलेंगे जब तक हम अपने लिमिटिंग लैटिट्यूड तक नहीं पहुंचेंगे, तब तक हम पैरेलल सेलिंग करेंगे.
फ्रॉम V1 बेटा
यस सर, V1.
Okay, from V1 we will go up to V2, Victor 2. Victor 2 is the second vertex.
यस सर.
Okay, so V1 to हाँ बोलो.
V2 हमें पहले कैलकुलेट करना पड़ेगा ना, मतलब
Yes बेटा, हमें V1 और V2 दोनों ही पहले से कैलकुलेट करने पड़ेंगे. ये दोनों हमारे वे पॉइंट्स होंगे. They have to be calculated before we start to proceed. Okay बेटा?
ओके सर.
सर
और बताओ बेटा.
सर इसको जैसे ये क्वेश्चन जो है ये V1 और V2 दोनों में ये पैरेलल सेलिंग होगी. जैसे इसमें सिंपल सा है, A से V1 का अपन GC निकाल लेंगे और यहाँ V2 से B का GC निकाल लेंगे.
राइट.
है ना, बीच वाले का पैरेलल निकालना है, तो अपने को V1 और V2 के वर्टेक्स चाहिए, वो भी निकल जाएगा। पर ये जो दोनों ये V1 और V2 होंगे, ये सेम उस पे नहीं होंगे, सेम सेम लैट पे।
हाँ दोनों सेम लैट पे होंगे बेटा, दोनों 50 डिग्री नॉर्थ पे हैं।
हाँ मतलब दोनों सेम उस पे होंगे, तो ताकि सीधे की सीधे डायरेक्टली अपन कैलकुलेट कर लेंगे कॉस्ट लेट से, तो बेसिकली ये पूरा अपना डिस्टेंस आ जाएगा।
राइट बेटा, दैट्स राइट, दैट्स राइट।
ठीक है, तो मतलब इसको 3 पार्ट में करना पड़ेगा, पहले 2 वैसे और एक इसका सेपरेटली।
राइट बेटा, दैट्स राइट, दैट्स राइट।
ठीक है सर।
ओके, सो वी आर ऑलमोस्ट। हाँ
कैसे
किसको बेटा, V1 V2 को
निकालेंगे कैसे? हमें तो इनिशियल पोजीशन या फाइनल पोजीशन ही पता होगी, दोनों पोजीशन एक साथ नहीं है हमें।
So next big question in our mind, how to find V1 and V2. Now since we are almost finished for this particular session, let's enjoy our lunch, and after lunch we will enjoy how to find V1 and V2.
तो V1 का लैट तो अपने को दिया हुआ है, V2 ही तो निकालना है, तो अपने पास इंटरमीडिएट पोजीशन का एक वही तो निकालना पड़ेगा, इनिशियल कोर्स, और वो तो होगा अपने पास।
अभी करेंगे बेटा लंच।
शिवांग enjoy lunch.
Yes, we will do it, don't worry. So have lunch and be back for the next session.
Yes sir, lunch के बाद करते हैं।
Right, so see you guys. हाँ बोलो अमित, you want to ask something?
ये सर इसी के रिगार्डिंग सर, ये जो प्लेन्स वगैरह होते हैं ये भी जीसी ट्रैक ही फॉलो करते हैं, इनका डिस्टेंस तो काफ़ी रहता होगा ना सर, फ्रॉम एक कंट्री टू दूसरी कंट्री।
राइट बेटा, दे फॉलो जीसी ट्रैक।
सर उनमें तो लैटिट्यूड का भी इशू नहीं होगा, हायर लैटिट्यूड वगैरह?
हाँ बिकॉज स्काई में आइसबर्ग होते नहीं।
वही ना, तो इशू तो होगा नहीं, वो तो डायरेक्ट ही कर सकते हैं, तो काफ़ी शॉर्ट पड़ता होगा उनको तो।
पर बेटा उनको थोड़े और इश्यूज होते हैं,
तूने अब तक फ्लाई
उनको और इश्यूज होते हैं।
फ्लाई तो बनवा लेता।
There have been instances where if a plane flies over some country which has not allowed the airspace permission, they may shoot down the plane.
करेक्ट सर,
एक
ठीक
बार
है
ऐसा।
सर, यही पूछना था कि जीसी ट्रैक ही करेंगे ना वो सर, ठीक है सर।
Right. So anyway, see you guys after lunch.
Okay.